James Webb Telescope just announced the true scale of the universe. What the James Webb Space Telescope just revealed changes everything we thought we knew about the universe. For decades, NASA astronomers believed the universe contained approximately 2 trillion galaxies. That number defined our cosmic census. That was our answer to the question, how many galaxies exist? Then the James Webb Telescope looked at the same patches of sky Hubble had studied, and the data came back staggering. The universe doesn't contain 2 trillion galaxies. It contains roughly 40 trillion. 20 times more. This isn't simply a larger number on a chart. This discovery fundamentally shifts our understanding of cosmic history, the probability of life beyond Earth, and humanity's place in an almost incomprehensibly vast universe. When we truly grasp the scale of what exists out there, something shifts in how we see ourselves. The James Webb Telescope launched in December 2021 with one critical advantage over its predecessor. It sees in infrared light. This allows it to pierce through cosmic dust and peer billions of years into the past. When astronomers pointed Webb at tiny sections of sky no larger than a grain of sand held at arm's length, they discovered galaxies Hubble had missed entirely. Faint, ancient galaxies so distant their light traveled over 13 billion years to reach us. As they analyzed the data, a clear picture emerged. The observable universe is far more populated than anyone predicted. But there's something even more striking hidden in these findings. Many of these galaxies appeared too mature, too developed for their age. Some had already assembled billions of stars in a universe barely 500 million years old. This contradiction raises profound questions about how galaxies form, how quickly they grow, and what cosmic forces shaped the early universe. For astronomers worldwide, this moment represents a turning point. We thought we understood the universe's basic structure. The James Webb Telescope revealed we were seeing only 5% of what actually exists. How do astronomers actually count galaxies? The universe is too vast for a direct census. Instead, astronomers use a method called deep field observation. They focus powerful telescopes on tiny patches of sky and count every galaxy visible there. Then they multiply that sample across the entire sky to estimate the total population. The Hubble Space Telescope, launched in 1990, revolutionized this process. Hubble's famous deep field image focused on a region of sky smaller than a grain of sand. In that tiny space, Hubble found roughly 3,000 galaxies. When astronomers extrapolated this across the entire celestial sphere, they arrived at 2 trillion galaxies as their best estimate. This number held for nearly 3 decades. It became the foundation for how we understood cosmic structure and evolution. The James Webb Telescope operates differently. Webb observes in infrared wavelengths, allowing it to detect light that visible light telescopes cannot see. Infrared penetrates dust clouds. It captures ancient light that has shifted so far toward the red end of the spectrum that it becomes invisible to human eyes. More importantly, Webb's infrared sensitivity reveals galaxies too faint and too distant for Hubble to detect. When Webb examined similar patches of sky, astronomers found substantially more galaxies than Hubble had observed. Not hundreds more, thousands more. When they ran the calculations, the new estimate emerged: approximately 40 trillion galaxies in the observable universe. The implications are sobering and profound. If 40 trillion galaxies exist, and each galaxy contains hundreds of billions of stars, then the total number of stars in the universe reaches numbers beyond practical comprehension. Yet this discovery created a scientific puzzle that astronomers are still trying to solve. Many of the ancient galaxies Webb observed were far more developed than current models predict. Galaxies in the early universe appear to have assembled rapidly, containing massive numbers of stars and complex structures. Some hosted supermassive black holes at their centers, objects containing millions or billions of times the mass of our Sun. According to our understanding of cosmic evolution, these black holes should have taken much longer to form and grow. This inconsistency forces astronomers to reconsider fundamental assumptions about galaxy formation, the behavior of dark matter, and the physics of the early universe. We may need to revise our models entirely. The true scale of the universe carries profound implications for humanity. Consider the search for life beyond Earth. With 40 trillion galaxies, each containing hundreds of billions of stars, the probability of Earth being the only world harboring life becomes vanishingly small. Statistical reasoning suggests that life, in some form, must exist elsewhere in the cosmos. We are almost certainly not alone. This realization connects us to something larger than ourselves. Every star in the night sky might host a planetary system.